Now let us look into this problem, which is under Newton's laws section, as you see in the sketch. Since the statement talks about friction experienced by this drone and mass m, so when we indicate forces around the mass m, we indicate tension force upwards on the cable. We indicate the weight force downwards. And because there is frictional force stated, that means we indicate two forces that are facing downward. That is weight and frictional forces. Then we calculate that frictional force experienced by this drone and mass m. First, we write the total net force around the drone. Net force equals mass times acceleration. Net force is the sum of lifting force minus tension minus frictional force minus weight force. On this side of equal sign, the mass of the drone is 5.8 kilograms, and acceleration is set to be 0.9. Lifting force is 180 newtons upwards. We make T a subject of the equation, then we label equation 1. Then we write the net force around the mass m. Net force is the sum of tension force minus frictional force minus weight force, all equal to mass times acceleration, which is 3.2 times 0.9 respectively. Weight force is 3.2 kilograms times 9.8. Tension and friction is unknown. We make T the subject of equation, and we label equation 2. We equate or solve the equation simultaneously. By doing so, we get a frictional force of 41.85 newtons. To find tension force on the cable, we take one of these equations to replace frictional force by this 41.85. By doing so, we get tension force is 76.09 newtons. To calculate power, we use this formula of power, which we need to have velocity and applied force. That velocity and applied force we need is given from this short statement, and applied force is this 180 newtons. Because it has not changed, we fill in this formula. We get power of 3,546. The unit is watts. If you like this video, please subscribe, like it, and refer the video to others.